You wonder how to go beyond text generation and use Google Vertex APIs to play with images and even go multimodal? Rejoice! The genie of the AI lamp will fulfill your wish. Let's start right away. In a previous video, we visited PaLM 2 models and API. Today, I propose to go beyond textual inputs and outputs and play with images and multimodality. But before starting, just some prerequisites to execute our API calls from Node.js in Jupyter. All right, so I create this utility function to run shell commands. And I will use this command that I just created to install two useful Node.js packages. The first one is ESM hook to be executed to install and run other Node.js modules easily. And then the .env to load and to manage environment variable from the .env file. So let's install those packages. While it's installing, let's speak a little bit about access token, because we'll need one to call the APIs. So to generate such a token, you connect to your Google Cloud Console. You activate, if necessary, the Vertex AI API. You create, if you need to do it, a service account and an API key. All right. And please note the location where your API will be accessed. Location in a Google Cloud way, so it's US Central, Europe Western, that kind of information and parameter. Then you install, configure, and launch the G-Cloud CLI. And then in this CLI, you will run the G-Cloud app locking. Then connect from the browser to the Google Cloud SDK. When it's done, you go back to the G-Cloud CLI, run the G-Cloud of print access token to generate and print the token in the CLI. Then you copy the value of this token in a .env file under the Google Access Token entry. All right. With that done, we'll be able then to first load the .env package into our execution context and the access token that we just created. All right. With that, now we're set and we can start to play with images first. All right. So in this tutorial, I'll stick to very simple API calls with the fetch Node.js command, just to concentrate on images and multimodality. So first, image generation. So we'll use the imagen model from Google. All right, and in the URL, I pass the platform that I access, the project ID. Here it's the value of my project ID on Google Cloud, the location that I was speaking about. All right, and the model. So the model is image generation. That's the name of the model, and we want to do prediction with this model. All right, then in the headers, I pass the token that I just load from my .env file. And then in the body, it's a JSON object with this structure. So there is an instance property where there is a prompt property, and I want to generate an image with this prompt, a robotic genie coming out of a magic lamp. All right. And the parameters, I just pass a simple parameter saying that I just want one image to be generated. Then I wait for the response to come back from the model. And then I will display the image in a HTML document that I created beforehand here with this special instruction. And then I inject the HTML and the base 64 encoded image returned by the model in this element. So let's run and discover what imagen created for us. So it's taking a little bit of time. Let's wait here. All right. Nice. Okay, so that's good. We can do other things with images. We can also do captioning. So captioning is very interesting when we want to have a description of an image. Then it can be useful in any business and use cases. I'll take an image from the FreePic website. I transform the image in a base 64 encoding. So here is the result of the encoding. Okay, it's on one line. And first, let's visualize the image and check that it displays properly. So when I run this code, I will just display the image. So basically, this is the image that I want to send to the model. This time, the model is called imagetext. So it's basically the same kind of API call, but this time I say I want to use the imagetext model. All right, and then in the instance property, I have an image sub property, and I pass the image in base 64 encoding in the object, in the prompt. All right, and then again, I want a single prompt in return, and I want the description to be made in English. And then I navigate and I display the result. So let's execute the code. So the promise is running, and then here's the description. A group of women sit on the yoga mats with their arms in the air. Well, that's true. Neat, interesting. Okay, we can also do with the same model, image text, also do some visual question answering. Basically, it's not far from captioning image here. So it's the same API call that I make to the image text, the same URL, but this time in the instance I also add a question to the image. So I have two instances: a prompt that is textual, that is a question that is passed to my function that I just created here. So for VQA, for visual questioning answering. All right, and then I will ask and display the result. And then I will ask three different questions on the same image. How many persons? Okay, in proper English, it's better. Are they in the picture? What are their genders? What are they doing? All right, let's execute the code and discover what image text answers. So it's women, they're doing yoga, and there are 5 of them. And you see the result, because it's asynchronous Node.js code executed, is the results are listed not in the same order as the question. Actually, we can see that the more easy the answer seems to be, the faster the answer have been answered by the model. So, but it's basically, let's see, 1, 2, 3, 4, 5. Yeah, they're all women, they're 5, and yes, they're doing yoga. So that's perfect, correct. Right, so we can play with images. What if we could play with both text and images? We started to do that with visual question answering and with captioning, but let's go multimodal. Here we discover a new kind. It's a brand new family of models released by Google DeepMind division. And the idea is, or the objective is, to reason seamlessly across text, images, and even video, audio, and code. All right. Currently, the model, they just output text or code, and they are still in preview mode. So it's a pre-general availability product. But that doesn't prevent us to start and play and test with them. All right. So model inputs in Gemini models are composed of several parts, and these parts can have different MIME types. There are 2 models currently available to preview. The first one is Gemini Pro. It's only textual part that are supported. And the second one is Gemini Pro Vision, where we can also have textual part, but also, have up to 16 images in one prompt, or 1 video of maximum 2 minutes. There are also some embeddings models. Let me correct this typo. So the first one is for textual only information. and it's a 768 dimensional vector that is returned. And then there is the multimodal embedding model that is combining both image and text, and the vectors are of higher dimension. Right, so let's start with the first model, the Gemini Pro model, and we'll mix in a multimodal way. We'll mix both text and code. Okay, so for the URL, then I just change here the fact that I want to use Gemini Pro, and this API is doing some streaming here. Okay, so the result, the response from the LLM will be a stream. Okay, but I won't deal with the stream in this code. I will just display the first chunks that are returned. So again, I pass the token to within the headers. Then the object in the body is slightly different. So now there is a contents property when you have, like in a multi-turn conversation that we saw in previous videos, the role of the user, and we have two parts. The first part is of type text, and I just put the start of some coding, like for var, etc., etc. And the second part is also text, and ask a question to the model. Please write a JavaScript function to count down to 1. All right, and then I pass general and generic parameters to the LLM, and then I want to see the answer. So depending on the configuration of the code that we do, we can have several candidates for answering. So here I will just display the first candidate that is returned, and actually the first chunk of the first candidate. So let's execute the code. Here we are. So we have an answer. So you see it's like in a chat multi-turn format. So the role is the model, and the model is answering with a part. So the first part is text, and you see again here it looks like he wants to display the code in a markdown formatting highlighting format. So it's called JavaScript, and then that's the beginning of the function. So countdown if whatever. So if I was dealing with the stream properly, I could get all the chunks and so get the entire answer. But for the demo and this tutorial, that's enough. We see that effectively the model is able to take both code and textual instruction and make an answer. All right. So that's good. Now let's go more visual, and let's add some images to the party. So now we'll use the Gemini Pro Vision. So again, it's there. I just say now I want to use the Gemini Pro Vision, and it's still a stream. Okay. Now in the content we have still the role of users, but now we have two different parts of different type. The first one is an image. It's the same image as the same image we were using before, the yoga woman. All right. Here, and we give also some text, and we ask the models to please give instruction to take the yoga pose shown in the picture. So you see the prompt is multimodal. It's composed of both an image and both a question that is using the image as part of the context. All right, and then again some generic parameters. I just don't really care about those right now for this demo. Okay, and then again I navigate through the answer and write down the result. So let's run this code. Okay, so now the model did answer with one part, which is textual, and it's the beginning, it's the first chunk. So to take the yoga pose shown in the picture, please first sit on the floor with your legs extended in front of you, then bend your right legs and blah, 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 blah. Well, that's pretty correct, because basically those women are on the ground, and it's just the beginning of how to take the pose that is displayed in the photo. So yes, that's cool. That's nice. We see multimodality in action now. All right, so now just to finish this very quick tutorial, Now let's speak about multimodal embedding. Of course, we can do textual embedding as with former PARM2 models, but I just wanted to illustrate the multimodal embedding. So basically, you change the model here, and it's multimodal embedding, the name of the model, it's prediction that we want to do. And again, I use the token, and then I want in the instance object, I just give two different parts. The first one is my own instruction to take the pose in the image. So it will be instruction for this pose: sit cross-legged, straighten your spine, whatever, inhale, undo, whatever. And the other part is an image that is encoded in base 64, and it's the same image as before. And then I just want to know what is the embedding vectors associated to this this multimodal prompt. All right, so let's run the code. And here we see something interesting. There are two vectors that are returned, and the vectors are of higher dimensionality. You see, it's 1,408 values in a vector. And you have two types of vector. You have the text embedding, and you have also the image embedding. So we are able to use those vectors, store them in a vector store, do some semantic search, and it allows to a lot of use case with image classification, for instance, or image search, or even recommendation based on the content of images. It's also very useful with captioning that we saw before. We can inject some metadata to image or to vectors, and it will be very useful to increase quality of RAG, for instance, retrieval augmented generation when it's based on image, for instance. So I can't wait to see also support of audio. Video is already supported, but I think that's enough for today and for this tutorial. So I hope now you enjoy how LLMs and Google in particular is creating new models to go multimodal and to deal with different kind of media in one prompt, even in inputs, but also in outputs soon, I hope. All right, thank you very much. And that's it for now. Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned. Bye-bye.